Hello, my name is Matthew Yeomans. Thank you for viewing my presentation. Today's presentation is going to be about electrocortical activity and postural control during eye-hand coupling and decoupling tasks in aerobically fit versus sedentary individuals. To start, let's go over some brief introductory information. Literature shows that neuronal changes exist in adults who have greater aerobic fitness compared to their sedentary counterparts. This improvement in aerobic fitness may lead to improvements in cognitive sensory-motor tasks, especially those that have a simple motor component. Our main research questions were to investigate whether eye-hand performance differences existed between sedentary and highly aerobically fit individuals when performing a more cognitively demanding task, and to see if cerebral activation or postural sway changes existed between groups or between tasks. 7 healthy young adults were used for the study. All of them were right-handed, and 4 fell into our fit category and 3 fell into our sedentary category, which was determined by the YMCA submaximal test for individuals aged between 18 to 25 years old. 2 conditions were used for the eye-hand coordination or coupling versus decoupling tasks. The coupling tasks, or EH tasks, involve the eye and the hand moving together to a peripheral target. The EHR, or decoupling tasks, involve the eye moving to the target as the hand moved away from the target, with a cursor providing feedback. Individuals were instructed to move as quickly and as accurately as possible and to stop in the center of each target with either their finger or the feedback cursor. 4 peripheral target directions existed, being left, right, up, and down, and they were presented in a randomized order for each trial. Hand tasks were performed during EEG collection as well as center of pressure collection. EEG variables were used, and they were calculated for delta, theta, alpha, and beta bands by taking the average activity during the trials for EH and EHR tasks, or coupling versus decoupling tasks, and subtracting the pre-measures taken before trials began. Spatial and temporal hand variable measurements were also observed, as well as normalized center of pressure variables. Now for the results. When looking at the left hand of the slide, we can see center of pressure data for fit and sedentary participants in both the EH or couple task as well as the EHR or decouple task. We can see that between the tasks for both participants, there's really no center of pressure differences, and that there are no center of pressure differences when comparing the 2 groups. Now, when we look at the graphs on the right, we can see hand endpoint error and hand response time on the top half, as well as EEG activations on the bottom half. When we look at the blue dot, this relates to the fit group, and when we look at the red dot, this relates to the sedentary group. For endpoint error time, we can see there are significant differences between the 2 conditions. The EHR or decouple condition has greater endpoint error for both groups compared to the EH or couple condition. The same is true for response time. When we look at the EEG activation, specifically the alpha and beta bands at a CP6 marker, we can see that the decouple condition has greater activations at this marker when looking at alpha activity compared to the coupled condition. When we look at the beta band, we can see the same is true. Now, when we look at the alpha band, there also may be a trending effect of differences between activations in each condition when comparing the fit versus the sedentary groups. Now for the discussion. Lower alpha power at the CP6 marker is likely related to improved cognitive and attentional control. This is because the lower power is typically assigned for increased cortical activity. The same can be true when looking at beta activity. The decreased beta power when looking at the coupled compared to the decoupled task may mean increased cortical activity in the area below, meaning improved motor control demands during the coupled task. There was also a trend for the highly fit group to have lower alpha power at the CP6 marker. Although this was not significant, it may mean that the fit groups had increased cortical activity by way of this lower power at the CP6 marker, which may mean improved cognitive, attentional control when looking at alpha activity. There were no significant differences between fit and sedentary individuals when looking at hand performance, contrary to other research. This could be related to the increase in the self-reported high levels of eye-hand coordination experience in the sedentary group compared to the highly fit group. It could also be linked to the small sample size. There were also no significant postural sway differences between groups or between conditions. This could be due to limited trial numbers compared to other research, but also could be related to the fact that force plate trials were always performed last, and there could be improvements with practice that also led to alterations in postural sway performance.